Good afternoon and welcome to today's briefing from the National Toxicology Program about its cell phone studies in rats and mice. This is a 60-minute call and it will include a briefing followed by a question and answer period. At this time, all participants are in a listen-only mode. You may register to ask a question at any time by pressing the star and 1 on your touch-tone phone. And when you are called upon to ask a question, please state your name and your news organization. Please note this call is being recorded. And we will now start the briefing, and I will turn the call over to Dr. John Bucher, Senior Scientist at the National Toxicology Program. Please go ahead, Dr. Bucher.
Hello, and thanks for joining the call. I'm Dr. John Bucher, former Associate Director of the U.S. National Toxicology Program, or NTP for short, and currently a Senior Scientist with the program. I'm joined by Dr. Michael Wide, Study Toxicologist for the NTP Cell Phone Radiofrequency Radiation Studies. The NTP is a federal interagency program headquartered at the National Institute of Environmental Health Sciences, which is part of the National Institutes of Health. NTP's mission is to coordinate toxicology research and testing across the Department of Health and Human Services, including NIH, the Food and Drug Administration, the National Institute for Occupational Safety and Health, which is part of the Centers for Disease Control and Prevention. One of our charges is to perform comprehensive toxicology and cancer studies on agents of public health concern. Since the inception of the NTP in 1982, we've studied thousands of agents, primarily chemicals, but also physical agents such as extremely low-frequency electromagnetic radiation. These are typically evaluated in experimental animal studies conducted with rodents, and are performed in response to nominations of agents for study from a variety of sources. The FDA nominated radiofrequency radiation emitted by cell phones for study. In May of 2016, we released a report on partial findings from the NTP cancer studies of cell phone radiofrequency radiation in rats. The report remains available and can be accessed through the NTP website. Today we are posting on our website the complete draft technical reports from our studies in both rats and mice. We are releasing the reports for public comment prior to review by a panel of outside experts in late March. Public release of draft reports is part of our standard process for peer review of our findings. These reports represent the conclusions of NTP staff. The expert panel will decide whether they agree with these conclusions and will consider public comments in their deliberations. These 10-year, $25 million studies have been some of the most comprehensive and technically challenging we've attempted. Our May 2016 partial findings release reported small increases in the number of exposed male rats that had tumors of tissues that surround nerves in the hearts and brains. The rats had been exposed to radiofrequency radiation starting in utero and then for 2 years following birth. The 2-year-old rat is of an age approximating a 70-year-old human. At that time, we said the tumors we observed were likely related to the cell phone radiofrequency radiation exposures, but we were more confident in this conclusion for the tumors found in the hearts than for the tumors found in the brains. Our complete findings released today conclude that the increases in tumors of nerves in the heart called malignant Schwannomas were due to the exposures to radiofrequency radiation in male rats. These tumors, seen in approximately 6% of the animals in the highest exposure groups, but none in the controls, are proposed for classification as some evidence of carcinogenic activity. The designation some evidence is the second highest positive category of findings in our descriptors of results. The highest is clear evidence of carcinogenic activity. After reviewing all of the data from these studies, the evidence for increased malignant Schwannomas in the hearts of male rats is the strongest cancer finding in our study. In our complete evaluation, we again had a lower level of certainty that small increases in the numbers of male rats with tumors in the brains were associated with exposures to cell phone radiofrequency radiation. These findings are termed equivocal evidence of carcinogenic activity, meaning it was unclear if the tumors were related to the exposures. We also determined that there was equivocal or uncertain evidence for a number of other tumors of various types in male and female rats and mice. The reports lay out the reasoning and the process used by the NTP to reach these conclusions. We saw relatively little indication of any health problems in mice from cell phone radiofrequency radiation. We also looked at other non-cancer health conditions like changes in body weight and other evidence of tissue damage. This included assessing evidence of damage to DNA and blood cells and the liver and brain of some of the animals. We saw somewhat lower birth weights in rats and some changes in the typical patterns of age-related degeneration in specific regions of the heart in male and female rats. Evidence of DNA damage was seen in some tissues of some animals, but we currently don't feel we have sufficient understanding of these results to comment on their biological significance. To conduct the studies, we used two modulations of cell phone radiofrequency radiation termed GSM and CDMA. The radiofrequency radiation modulations and frequencies we used mimic those used in 2G and 3G networks, which were standard for cell phones when the study was designed. Current wireless communication networks like 4G and 4G LTE continue to utilize the earlier technologies for their voice calls and texting components. It's important to consider the magnitude of the exposures to the animals in these studies in relation to what one might typically receive from using a cell phone. The lowest energy level of the radiofrequency radiation we studied was similar to the highest level currently permitted for cell phone emissions to local tissues. And I'll explain what this means in a second. The exposures to our animals were to the whole body, meaning each organ, such as the brain, heart, or liver, was potentially exposed to radiofrequency radiation at what's termed a specific absorption rate, or SAR, of 1.5 watts per kilogram for a little over 9 hours per day throughout the studies. The current limit for human exposures to cell phone emissions is 1.6 watts per kilogram in a defined local area close to the cell phone when held next to the body. This maximum energy level is only approached when the phone is having difficulty in making or maintaining a connection with the base tower. Energy levels of emissions during a typical call are much lower than this highest permitted level. So keeping this in mind, the energy levels used in the rat studies were 1.5, 3, or 6 watts per kilogram, and those for mice were 2.5, 5, and 10 watts per kilogram. Now, earlier I mentioned that the organs of the animals were potentially exposed to these energy levels, but not all organs absorb radiofrequency radiation energy to the same extent. One of the manuscripts that describes the technical aspects of our study by Gong et al. Includes simulations that predict the relative absorption rates of different organs. This publication, which is on our website, predicts absorption of energy by the heart to be relatively high in relation to other organs. Now, lastly, I'd like to acknowledge that the equipment used to expose the animals was designed and constructed in collaboration with experts from the National Institute of Standards and Technology here in the United States, the ITIS Foundation in Switzerland, and IITRI laboratories in Chicago. The actual animal exposures were carried out at the laboratory in Chicago. The next step for these reports is to convene a scientific peer review by experts from outside the NTP. These scientists will fully vet all aspects of the performance and reporting of our studies and our conclusions. The reports have been posted to the NTP website so the public has an opportunity to read them and provide comments. The peer review meeting will be held March 26 through 28 at the NIEHS in Research Triangle Park, North Carolina. And a final word is that these experimental animal studies are but one approach to understanding whether exposures to radiofrequency radiation pose a risk to human health. Studies continue at the NTP on the molecular changes in tissues from these animals And our partners at the National Cancer Institute and at research institutions around the world are actively engaged in monitoring cancer incidences in humans and conducting epidemiological studies to evaluate exposures to these evolving technologies. And with that, thank you, and we're happy to take your questions.
Thank you. And at this time, if you'd like to ask a question, please press the star and 1 on your touch-tone phone. You may withdraw your question at any time by pressing the pound key. Once again, to ask a question, please press the star and 1 on your touch-tone phone, and we can pause a few moments to allow questions to enter the queue. And we can take our first question from Paul Kirby with TR Daily. Please go ahead. Your line is open.
Thanks for taking my question. My question is, in the press release and in this call, you said that you can't really extrapolate because your lowest power was the highest power allowed in cell phones. So if you were trying to see whether there was a link between exposure to and these various tumors and other things, why did you use mostly higher powers than people would actually be exposed to using their cell phone?
So this is a typical way that toxicology studies are done. We are trying to understand the potential biological effects of a technology that has been traditionally predicted to not be particularly damaging or to tissues. In toxicology studies, we are projecting, in essence, the results over a large population of individuals who are actually exposed to radiofrequency radiation. Individuals may have a variety of different sensitivities to radiofrequency radiation, and it's important that we challenge animals to levels at which we believe these exposures are still relevant to human exposures, but they need to be challenged with respect to detecting effects. I will say that the studies that we did were designed to limit the exposures to these animals to those that were lower than those that would cause greater than a 1 degree centigrade in body temperature, which is part of the guideline regulations that currently govern how much exposure you can receive as a human being using a cell phone.
Thank you.
Thank you. And we can go next to Maggie Fox with NBC News. Please go ahead. Your line is open.
Thanks. I'm wondering if you can characterize if there's much new that you have learned since 2016. And I remember the last time we asked you if you in particular had changed your cell phone use. And I'd like to ask you that again. Have you changed your cell phone use or what you recommend to your family based on these findings? Thanks.
So in finishing these studies, we have evaluated the entirety of the tissues. We have come up with a number of what we're terming equivocal findings, but in general, the only positive finding that we've really been able to have confidence in, I think, is the malignant schwannomas in the heart, which is what we described in the 2016 report. I think that it's important to be able to put all of the findings in the report in the context of understanding what happened across the entire body of animals throughout the experiment. So we've done that. We're reasonably sure we understand what's going on in these studies at this point, and the reports that you can see on the web outline the full findings. That said, I think that the reports don't go much further than what we had reported earlier, and I have not changed the way I use a cell phone, no.
Thank you.
Thank you. And we can go next to Ryan Knutson with Wall Street Journal. Please go ahead. Your line is open.
Great, thanks. Just quickly, I just to follow up on that, the previous reporter's question, did you recommend anything for your family, whether or not it's changed? But then also my main question is, you say that in the report that there was significant increases of DNA damage in some parts of the mice and rats and certain parts of their brains, like the frontal cortex, but then that you aren't sure what it means, what the biological importance of that is. Can you elaborate on that a bit? Isn't finding DNA damage significant because non-ionizing radiation was always thought to not be possible to damage DNA? Are you sort of saying that you're not sure if it has anything to do with RF exposure?
So the first question was, have I recommended changes to my children? And no, I have not recommended changes to my children in the way they use it.
Not changes, but do you tell them to use a headset or anything like that, or just you don't tell them to do anything? That's
I have not really addressed that issue with them. The genetic toxicology findings in the report, I must say we, as I indicated in my remarks, are puzzling over them. We would like to see, and in fact plan to repeat these results when we complete the exposure chamber facility that we are constructing currently to do some follow-up studies on the cell phone study findings that we've made to date. The patterns of damage in the brain to the tissues in the brain of these animals were not particularly consistent with what we saw with the tumor outcomes, and were not consistent even within a particular animal across the brain. So we have some questions. We've looked quite a bit into the technical aspects of how the studies were carried out, and we can't really identify any particular reasons for the findings that would be explained from the standpoint of technical artifacts. So at this point, we really just don't feel like we understand enough about the results to be able to place a huge degree of confidence in the findings.
Thank you. And we can go next to Lauren Niergaard with Associated Press. Please go ahead. Your line is open.
Hi, thank you. So I have a couple of questions about what takeaway messages we can actually glean from this. The findings were so different in rats versus mice. Are we even studying the right animal model here? Does it tell you something to go forward with that takes this into a realm that is more applicable to current human use?
So the rats and mice in these studies were actually exposed to different frequencies of radiofrequency radiation. In the studies leading up to this large 2-year study, we performed some simulation exposures of animals to try to understand the types of radiofrequency radiation that might be highest with respect to being absorbed by the particular animals, and found that the 900 megahertz frequency was absorbed more readily by rats, and the 1900 megahertz frequency was absorbed more readily by mice. There's still a question as to whether frequency in and of itself and the changes in frequency could alter the outcome in these animal studies. So the fact that rats and mice seem to be responding somewhat differently is not necessarily, can't necessarily be determined from the studies that we did. Rodents are generally considered to be reasonably good surrogates for toxicology and cancer studies for humans. The issues in studying something that at best might be a weak carcinogen, which I think everybody would classify radiofrequency radiation, if in fact it is a carcinogen, that would require large numbers of animals and exposure setups and things that would be very, very difficult to accomplish. So we think that the technical aspects and just the simple ability of exposing animals to a situation that might reveal a radiofrequency radiation-induced damage or, in fact, cancers really requires that we use rodents at this time.
Thank you.
And we can go next to Denise Grady with New York Times. Please go ahead. Your line is open.
Hi, thanks for answering this. I'm just wondering, in the reports, how many individual studies do they actually encompass? And if it's even possible to give an estimate or an order of magnitude, how many animals were involved in these studies over this time period?
So the main studies involved rats and mice, males and females, that were exposed to either the GSM or the CDMA radiofrequency radiation. The total number of animals was approximately 3,000.
Okay, thanks.
Thank you. And as a reminder, if you'd like to ask a question, please press the star and 1 on your touch-tone telephone. We can go next to Todd Shields with Bloomberg News. Please go ahead. Your line is open.
Hi, thank you. I'm interested in the takeaway for people, for humans. Do people need to be afraid of their cell phones? I mean, what should we say to the man on the street?
So as I indicated before, the typical cell phone call has radio frequency radiation emissions that are very, very, very much lower than what we studied. We studied, as I indicated, the maximum that one could achieve during a call in a poor connection situation, and we studied it over 9 hours a day for over 2 years. So this is a situation, obviously, that people are not going to be encountering in utilizing cell phones, but again, it's a situation that allows us to express a potential biological event or find a potential biological event if one is going to occur. So I think that the message is that typical cell phone use is not going to be involved in, is not going to be directly related to the kind of exposures that we used in these studies.
Thank you. And we can go next to Aaron Ross with Axos. Please go ahead. Your line is open.
Hi. I was curious if you have any new ideas as to why there might be differences between the response in male and female rats since this first was published in 2016.
Yes, actually, we have in looking at these reports as a whole, the responses did seem to be more severe, if you will, in male rats than female rats. And in what we called our pilot study phase, where we were looking at the levels of radiation that increased the body temperature of animals over 1 degree centigrade, we found that the larger the animal in general, the greater absorption of energy from the radiofrequency radiation, and the higher the body temperatures. And as rodents grow, and rats and in particular male and female rats grow at different rates, male rats achieve a body weight that's several hundred grams higher than female rats generally. So we think that if any of the groups of animals, either male or female rats or male or female mice, were to show an effect, we would have expected it in the male rats.
Thank you. And we can go next to Charlie Schmidt with Science Insider. Please go ahead. Your line is open.
Sure. I wonder if you can speak specifically to the dose response. Were the effects that you were seeing definitely in the highest exposure ranges? Did you see any kind of threshold below which there was no effect?
We did not see a threshold in our particular studies. The malignant schwannomas occurred with a dose response. There were several other biological effects that occurred with dose response. And there were a number of statistically significant changes that occurred in tumor incidences for a variety of tumors that we did not see a dose response. And we believe that, in fact, this sort of diminishes the confidence that we have in these findings. So dose response was one of the particularly important aspects of deciding whether there was some evidence of carcinogenic activity or, in fact, was equivocal evidence or was an uncertain finding.
This is Michael Wyde. I just wanted to expand on John's comment. In the lesions for the heart, the schwannomas, we also saw a statistically significant trend with increasing exposure. And also we saw statistical significance pairwise at the highest exposures, the 6 watts per kilogram. And again, in those control animals, we actually saw none of these lesions, which indicated that this was a very rare lesion in these animals.
Thank you. And we can go next to Susan Wagner with NBC News. Please go ahead. Your line is open.
Yes, thanks for taking my question. I'd like to go back to the difference between the male rats and the female rats. Is there any way we can extrapolate that to humans, to men and women?
We don't, at this time, we don't have any ideas that would really allow that to be done. No, I'm sorry.
Do you have any understanding for the difference between that in terms of their hearts? What's the difference between a male rat's heart and a female rat's heart?
So there are obviously differences in the endocrine system and the way hearts age and respond to various stressors. But in this case, we think that since the females were also showing strange, if you will, unusual patterns of cardiomyopathy, which is a naturally occurring age-related degenerative condition in the hearts of rats, we did see with the radiofrequency radiation, we saw increases in sort of a different pattern of this disease. We did see it in males and females. But again, I think that the tumors were showing up in males, likely due to the fact that they were simply absorbing more of the radiofrequency radiation than the females. I mean, that's as good an explanation as we have at this point.
Thank you.
Thank you. And we do have a follow-up question from Ryan Knutson with the Wall Street Journal. Please go ahead. Your line is open.
Thank you. I was hoping you could talk a little bit about some of the other biological observations, such as the birth weight being lower in the exposed group, and then sort of more broadly, since it seems like these results are sort of somewhat mixed, what do you think this says about just sort of the simple notion that there can be biological effects from this type of RF exposure, but even if it's unclear what that actually means for people's health?
So I think we do report in the reports. When you read those reports, I think you'll see a fairly large number of indications that there are in fact biological effects. The birth weights were lower generally in rats in the perinatal portion of the study, meaning at birth and during early life lactation, and this was pretty much in an exposure-related manner. We don't know whether this is a direct effect yet on the what they call rat pups, or if this is an indirect effect, perhaps related to the way the moms, the mothers, the dams of rats actually cared for those animals during lactation. We don't have any idea really of, because of the configuration of the chambers, we weren't able to actually observe the behavior of those animals during the exposure period. So there could be effects related to the maternal behavior that were somewhat different in the chambers, or there may be other effects. We don't really know. At this point, probably one of the stronger effects that we saw in the study was a decrease actually in age-related nephropathy, which is a degenerative kidney disease that rats typically get, and typically you see that in males more so than in females. And in fact, in this study, if you remember back to the May 2016 report, one of the findings that we also report again, it's the same study, were that the control male rats lived a shorter amount of time than the exposed animals. And we found that in carrying out the complete evaluation of these animals, that the condition of chronic progressive nephropathy was decreased in an exposure-related manner across the radiofrequency radiation exposure levels. And clearly, this is also an evidence in a positive sense with respect to the radiofrequency radiation that there are biological effects of exposures to this test agent.
Thank you. And we can go next to Seth Borenstein with the Associated Press. Please go ahead. Your line is open.
Yes, actually, my question was to follow up on that. In terms of, if you weigh now both the increase in the heart schwannoma and then but the higher survival rate of the radiated rats, can you weigh those two against each other? In the long term, it looks like the radiated rats live longer, so wouldn't that be a better thing than? I guess how can you explain this to people that, hey, there are more tumors, but the radiated ones also live longer? Why is, what should people take home from that?
So there's two levels to that question. One is the specific aspect of the living longer on the tumor incidence. And I will say that we did survival-adjusted statistical evaluations in our studies so that, in fact, the increases in heart tumors were not solely due to the fact that the animals lived longer. They actually did have an increase, statistically significant increase. But I would say also that, we don't always, in a variety of different chemical evaluations, chemical assessments, we've seen both positive and negative effects with respect to an ultimate effect of a chemical on an animal's physiology and biology. So it's not necessarily unexpected. I recognize that it's a difficult message to get across, but in fact that is the case in this situation.
This is Michael White. Also, when you look at the survival, I think what you're asking is how the survival might impact the development of a tumor. So when we look at the schwannoma specifically, these don't only appear at the very end of the study. These we started to see towards the end of the study. This occurred before we had more significant loss of pups or of animals in the control groups. So as opposed to what we looked at in the brain, these were very late occurring tumors. So if the animals were living longer, it's possible that the length of time that they lived might contribute to the fact that they had a longer time to develop the tumor. But for the hearts, we believe that this occurred earlier on in that stage, so we believe that that this is not necessarily specifically related to the survival of the animals.
But I guess what I'm getting at is for the average person, if you say you may get and granted you're not saying these extrapolate to humans, but you may get a heart tumor, but you may live longer. The average person will say, I'd take the heart tumor and live longer. I mean, I guess so. That's what I'm trying to understand. Are you saying that this is necessarily a better thing?
So what we're doing is that we're actually simply reporting the findings that we have in these studies. And I mentioned earlier that these studies were done using exposure levels that are unlikely to be encountered by humans. So the extrapolation of these findings to potential for risk for human health is something that requires a number of different steps that go beyond the particular realm that we're studying here, that we're reporting here. So I don't think that question is particularly answerable at the moment, though.
Thank you.
And we can go next to Brenda Goodman with WebMD. Please go ahead. Your line is open.
Oh, hi. Thanks. I was going to ask about the lower survival rates too. That's a puzzling one. Do you have any thoughts about why?
Well, there are really two proposals, and that is the one that this is a chance effect, and I think that there may be some truth to that. There also is a potential that this is a real biological effect due to the known use of microwave therapies in what's called microwave diathermy to treat tissue injuries and reduce levels of inflammation. In the chronic progressive nephropathy in our male rats, one of the key features is an inflammatory reaction. And in almost all of the organ systems that we evaluated, this inflammation was in fact occurring at a lower level than in the control animals that hadn't received the microwave radiation. So again, it's a complicated situation here. We're seeing positive and both positive and negative effects in these animals.
And can you, I know this is going to be difficult because there have been so many different studies, but can you put these findings into context a little bit for us of other major cell phone studies like Interphone? I mean, how do we assess all this information taken together? Are you telling us really we have to consider this as its own discrete piece of information?
No, actually, I'm saying that this is part of a much larger set of information that has to be considered with respect to determining any risk to human health. The Interphone studies and a number of other earlier epidemiology studies still have produced conflicting evidence as to whether there are increases in brain tumors as well as tumors called acoustic neuromas or vestibular schwannomas of the 8th cranial nerve in humans using cell phones in a very heavy rate. One of the things that we found most interesting about our findings was that the malignant schwannomas, even though they occurred in the heart and not in the head of these animals, were in fact schwannomas, and schwannomas are the same type of tumor that's found on the acoustic nerve in humans in the earlier epidemiology studies. So I'm not saying that our studies should be taken only in isolation, and in fact I think that, as I indicated in my remarks, you need to take into consideration the entirety of the epidemiology literature. You need to take into consideration the number of animal studies that have been done in the past, and they number almost 20 now, animal studies of cell phone radiation, with the vast majority of them coming up negative with respect to cancer. We have in the report pointed out a number of the technical difficulties with some of those earlier studies that actually led us to do the studies that we're reporting today because of what we felt were some technical improvements that we could make in the study designs. But again, I think that absolutely one needs to take into consideration all evidence before reaching conclusions about public health implications of our study.
Thank you.
Thank you. And we can go next to Laura Kelly with Washington Times. Please go ahead. Your line is open.
Hi, thank you for taking my question. I wonder if it's possible you could talk maybe about just one surprising finding to you that you didn't expect.
Well, I think the surprising finding to me was the malignant schwannomas. I think that given the history of findings in these studies, we were surprised by this. I was also surprised at the chronic progressive nephropathy decrease that we found, and I think those two things sort of stand out.
Thank you. And we can go next to Erin Ross with Axos. Please go ahead. Your line is open.
Thank you. I haven't had a chance to look closely at the numbers in this because they did not post it noon. They posted it like 12:45. But I remember that in the 2016 report, one area of concern was that the control group in this particular strain of rats is prone to cancers, and they found that and some people criticized that the rates were extremely low. I was curious if the anomalously low rates in the control group were present also in this in the 2018 update, and then I was also curious with regards to the nephropathy. You mentioned that there's a type of microwave therapy used in kidney inflammation. I was just wondering if you could repeat that type that has been used in the past. I didn't get the full name when I was transcribing.
Well, the therapy that's used is microwave diathermy.
Could you spell that?
I think it's Diathermy.
Thank you.
So I'm not exactly sure I understand entirely the first part of your question. The particular rodents that...
There were criticisms that the rates of cancer in the control group were lower than you would expect just by normal occurrences. I was curious if that was still true in the 2018 update.
The original report, I think what you're talking about is the fact that we saw no tumors in the control animals in the hearts or in the brains. And this is not a totally unexpected occurrence. These are rare tumors. We would see a tumor about 1 in every 2 or 3 studies that we would do, and there were none that showed up in this particular study. So it's not that unexpected that you would have a study and that would not see these tumors in a control group.
Thank you.
Thank you. And we can go next to Joel Moskowitz with the University of California at Berkeley. Please go ahead. Your line is open.
Thank you. As I recall, the early toxicology studies on tobacco found a whole host of low incidence tumors in various organs of the body, and people just sort of ruled them out because there's the belief that an agent wouldn't cause tumors in various organs. There was a U.S. Air Force study conducted from 1980 to 1982 looking at very low intensity microwave radiation, 2450 megahertz at much lower exposures than you were using in this study, from 0.15 watts per kilogram to 0.4 watts per kilogram. And what they found looking at male rats was that 18% of the male rats exposed to this form of microwave radiation over a 2-year period developed cancer, as compared to only 5% of the rats in the sham-exposed control group. This was called the Guy study, but it was actually published later on in Bioelectromagnetics, and Chow was the first author on the paper. So this is a peer-reviewed study. So the relative risk they reported of developing cancer across these different types of tumors in different organs in the wireless radiation exposure group compared to the sham control group was 4.46, which was highly significant. If you were to look at your data from that standpoint of the proportion or the relative risk of developing any type of tumor in the rats and then also in the mice as compared to the sham controls, what would you find?
So we have looked at that. The female rats and the male and female mice showed total tumor incidences across the groups that were about equal across the control and the exposed groups. There were slight elevations in the male rats in total tumors, total incidence of animals with tumors. It's hard for us to actually interpret these findings because total incidences of tumors are generally driven by common tumors, not driven by these rare tumors that we've been reporting in this study. So we haven't really done the evaluation completely with respect to the point that you're raising. I will say that the survival difference would magnify this issue related to total tumors, and that the control animals would be affected, I think, more so than the incidences where you have a particular incidence of a rare tumor. I think they would be more affected in this case. So we'd really have to dig into that in a little more detail to decide exactly how to answer that question.
Thank you.
Thank you. And we can go next to Andrew Joseph with STAT. Please go ahead. Your line is open.
Yeah, thanks so much. I'm sorry to harp on this again, but with the survival data, I know the difference between the exposure and the control arm was found with male rats, and I was just wondering if there was any noticeable difference either in female rats or in the either sex of mice.
Well, there were slight differences. In general, if you look across the studies, there was a slight increase in lifespan in the exposed animals compared to the controls, but these were not statistically significant differences.
Got it. Thank you.
Thank you. And we can go next to Charlie Schmidt with Science Insider. Please go ahead. Your line is open.
The other studies, and would I describe this as the largest, most comprehensive animal study to date, or what's sort of the magnitude of this study relative to its predecessors or the others that are ongoing? Assuming you want to answer that.
I can answer that from the standpoint of the typical studies, and that is that typically one would run studies. A cancer study has about 50 animals per dose group. You might run 2 dose groups and a control. You might run rats, 4 mice, and in this case we've run 90 animals per exposure group, including controls. We've done males and females, rats and mice. We started the exposures in utero in rats, which is a whole another dimension, adds another dimension of exposure scenario, because I don't know of any of the other studies that have used in utero exposure. I could be wrong on that. And well, they were large studies, let's put it that way, and technically very demanding studies. And in this case, we were able, because of the design of the exposure scenario, we were able to expose animals, free-ranging animals, if you will, not held within a particular restraint device to allow the radiofrequency radiation to be directed specifically at the head of the animal or something else. But these animals were exposed over their entire bodies for greater than 9 hours a day for over 2 years. So this is an extensive study, and we think that that's an accurate characterization.
I would also expand that to say not only was the size of the study itself, as far as the number of animals and the scope of the study, not only was that large, but this also involved the development of a novel exposure system, the testing and validation of that system, and the construction of a facility where we could expose the animals.
That's the one in Chicago?
That's correct.
Okay.
All right, and we can go next to Todd Shields with Bloomberg News. Please go ahead. Your line is open. Todd Shields, your line is open. Please check your mute function.
Hi, yeah, mute function, my bad. I'm told by a reporter who knows more about this stuff than I do, to ask, was the increase in malignant schwannoma in rats statistically significant?
Yes, it was.
Okay.
By trend test in one case and pairwise as well as trend in the other.
Okay, and if I could have a quick follow. In the news release, you say you caution against extrapolating to humans, but then you also say the following. We note, however, the tumors we saw in these studies are similar to tumors previously reported in some studies of frequent cell phone users. So do they buttress these earlier reports of tumors in cell phone users, and doesn't that say we should indeed draw a link to human cautions? I'm a little confused by the direction of that.
So the association, I mean, one of the things that drew our attention to this particular tumor type was the earlier reports of schwannomas, and I indicated that. There have been sort of an evolution, I think, in the way cell phones are used and in the technologies. I think that they're moving more and more towards lower power exposures to humans. One of the big pushes is to prevent the rapid battery decline that happens in a high power situation from a cell phone. So I think the technologies are really moving us away from some of the the exposures that would have been happening when they were moving from the 2G, especially, well, the 1G, the analog systems, to the 2G, early 2G systems, where there were fewer base stations or base towers and potentially higher phone powers being used at that time.
Thank you.
And we can go next to Ed Friedman with Friends of Mary Meeting Bay. Please go ahead. Your line is open.
Thank you. A few quick questions. You've mentioned that you've said that this is an unlikely exposure that these test animals have underwent. On the other hand, clearly there's a great deal of ambient exposure that people have beyond just being glued to a cell phone. Can you relate one to the other, i.e., does the period of exposure time with your test animals maybe compensate somewhat for the other exposures that people receive? And then rats and mice, do you consider them sort of equal opportunity test animals, or are there plans to maybe look at the same exposures in both species, and would you expect a difference? And then just lastly, any plans for looking at probably the most common wireless frequency, 2.4 gigahertz or thereabouts? Thank you.
So in answer to your first question, we're kind of living in this wireless environment where we're exposed to Wi-Fi and cell phone radio frequency radiation and electromagnetic fields. The way that I understand it is that the exposure from the cell towers themselves is negligible unless you're very close or working on those particular towers. So primarily human exposure is through use of handsets that use the wireless communications technologies that we researched.
Okay, thank you. Of course, people have smart meters and tablets and all these other things that
right,
are fairly close. So.
Right, so that's one of the concerns, and so our research, depending on what types of frequencies and modulations those use, these studies would be applicable to those technologies. And again, we're not experts on the exposure side, but it's my understanding from discussing with experts that the exposures are rather minimal from these other sources. But again, these are sources of exposure, and those need to be further investigated.
So I'd like to add to that one of the things that you mentioned is that there are different frequencies used in different technologies, and we acknowledge that. One of the things that I think will come out of these studies that's a great advantage to us is that we, through continuing some of these molecular studies into the tissues of these animals and knowing what happens with the particular frequencies and modulations that we've used, we can design short-term studies to be much more flexible and try to keep up with the changing technologies by monitoring some of the molecular changes that we've seen in these studies, in newer studies. And hopefully we'll be able to do something about keeping up with the rapidly advancing technologies with respect to assuring cell phone safety in the future.
Okay, thank you. That sort of gets to my question about the 2.4, what your future plans might be. I understood that the old reverberation chambers were destroyed. Maybe that's not true, but I heard you say you're making some more. So are you thinking about moving ahead with follow-ups based on what you've done?
Yes, we are. The reverberation chamber system that we used was large and not suited for the kind of small rapid studies that we need to do, and it could not be modified to accommodate all of these various different technologies. So we're building a much, much smaller but a much more flexible system to be able to move forward with these studies.
Any timeline on that?
We're hoping to have the facility in place by late summer.
Okay, thank you. Thanks for your work.
Thank you.
And we can go next to Melissa Chalmers with EPIC. Please go ahead. Your line is open.
Yeah, hi, thank you. Yeah, you mentioned about the exposure in rats and mice not being typical for regular exposures people have during the day. And I was just a little concerned about that, just because there are many people that don't realize that they are increasing their exposures by doing things like making a cell phone call from inside a metal building or their basement or, in a moving car. And then on top of that,
there are, a great many people who don't know what the distance is that these phones need to be from their body or their head, and they don't look in their user manual, and they exceed the safety code recommendations for their phones. So I just didn't want people going away with, thinking that they're not usually actually getting to these levels that would have been experienced in your study.
Well, we've tried to indicate what those levels are so that the community can evaluate this information and put it into the context of everyday use. I think that when we started these studies, there were not great measurements in the literature of sort of the ambient exposure levels, and we're hoping that we actually believe that some of that work is being done. So we'll have more of a database on which to put these studies into context and moving forward.
Yeah, okay, thanks. I was just concerned because there was a couple of people, from the media that had called in and were, trying to get a firm answer as to whether or not it's safe or not and how this relates to the world. And most people don't realize, what the phones are doing. They've never, measured them or done anything with them to know. So I just, with my experience with helping people who are having problems with this technology, often nobody realizes the exposures were as high as they were until afterwards. So anyway, thank you very much.
Thank you, and we can go next to Louis Selseman with Microwave News. Please go ahead. Your line is open.
Thank you very much. A quick question about the length of the exposures. Originally, the study was going to be a lifetime study, and at the last minute, it was decided to make it a 2-year study, exposure study. I'm wondering whether there are any trends that you now wish you could have followed through the lifetime, or you think you've learned as much as you could from the 2-year exposure.
Well, actually, I don't think with respect to the rat study, we could have gone much longer. The control animals were, as I indicated, and you know from the earlier report, were not living as long as the exposed animals. So to carry the exposures out further would actually make the statistical adjustments for survival more difficult to do. So from that standpoint, I don't think that would have helped any. And I will say from a technical standpoint, it's very difficult, not only from a statistical standpoint, but from a technical standpoint, to just keep chambers going of that size for a very small number of animals.
And for the mice?
I'm sorry, for the mice. Mice generally don't live quite as long as rats, so we're actually, well, I can't answer that question. I can't tell you what would have happened had we taken the mouse study out to the end of their natural lifespan. We didn't do that.
I guess my question is, are there any trends that you saw that you wish you could have seen? I'm not asking you to predict what would happen, but were there trends there that you might have liked to have followed through on?
No, I don't think so. If you look at the mouse report that we've put out and send us some ideas if you have some. That would be help us and interpret these studies.
Thank you.
Thank you, and we have time for one more question. We can go next to Jeanne Interlandi with Consumer Reports. Please go ahead. Your line is open.
Thank you so much, and apologies if this is repetitive. Also, excuse me, I have a touch of flu. I believe you said in response to an earlier question that your understanding is exposure is really, like, the big risk for exposure comes through handsets and devices that you're using closely. And I was wondering if there's any real concerns about 5G. Some things have been raised in the media about how as we move to 5G, there'll be more base stations required in places that are in closer proximity to where people live. And it sounds like maybe that's not necessarily a thing to worry about. I wanted to make sure I understood that correctly.
Well, first of all, I wanted to state that you indicated that there might be a risk, a high risk, if you will. I'm not sure if that's what you meant, associated with cell phone use at this time, and I don't think that's a proper characterization. I don't think this is a high-risk situation at all. But I will say that there's a sort of a trade-off. In moving to the 5G networks, you're going to be decreasing the distance between a cell phone or a smartphone of some sort and the station to which it's sending its signal. So it's going to be running at a lower power. So although I know that people are not happy with the proliferation of these antennas in their neighborhoods, it does in fact decrease the power that it takes the phone to connect to a base tower. So it's a trade-off.
Thank you, and I didn't mean to imply that the risk was high, only that people have expressed concerns that there will be an elevated risk in response to 5G, so apologies if I misspoke, but thank you.
The studies at the National Toxicology Program have, in fact, started. Our studies are designed specifically to mimic the human exposure scenario. The NTP studies are looking at exposures for 10 hours a day. There's heavy cell phone users that may approach the 10-hour mark. That may be excessive, but it allows us to fully investigate whether or not there is an effect of cell phone frequency radiation. Our studies are designed to look at the frequencies that are currently in use in the United States, centering around 900 megahertz and 1900 megahertz, as well as the two modulations that are currently in use in the United States, which are CDMA and GSM.
So just to summarize from our 2-year studies in the rats, what we've got so far, we see that there's body weights at birth and throughout lactation during exposure in utero tended to be lower than controls. It seemed like the animals that were exposed in utero were smaller. Their growth rates and body weights throughout the course of the study seemed to be similar to controls. This was an effect that was observed early on. In general, we saw that survival was higher or greater in all the groups of GSM or CDMA exposed animals in the male rats compared to the controls. We saw an increased incidence of schwannomas observed in the hearts of male rats at 6 watts per kilogram. This was a significant SIR-dependent trend for both the GSM and CDMA exposure modulations. And there was a significant pairwise increase in the CDMA exposure at 6 watts per kilogram. When we look at the brain, we see that there was a specific SIR-dependent trend in the CDMA-exposed incidence of gliomas in the brain of male rats exposed to RFR, but we do see in general that there was only an incidence of the schwannomas, the gliomas in treated animals and none in the controls. Again, we saw no exposure-related effects observed in the brains or the hearts of female rats. So we concluded from this data that the hyperplastic lesions and the glial cell neoplasms of the heart and the brain observed in the rats are considered likely the result of exposure to whole body GSM or CDMA modulated radiofrequency radiation. There is higher confidence in the results that we observed in the heart than what we observed in the brain, and that exposure female rats did not affect the incidences of these lesions in the brains or the hearts of the females. For the micronucleus, there was no significant increase in the micronucleated red blood cells in rats or mice. But when it came to the COMET assay, we looked at several different subregions within the brain, as well as the liver and the blood, and we found somewhat mixed results depending on the tissue and the brain regions, and depending on whether it was rats and mice. We also saw what seemed to be responders and non-responders, and so this is a graph that I pulled from the manuscript that was just submitted, and this is the incidence of the mean percent tail DNA in control, 1.53 and 6 watts per kilograms, and you can see that there is a significant trend when you look at all the exposures, as well as a significant pairwise increase here in this middle dose group. But what you find is it seems as though there may be responders and non-responders. It seems like there's some very high effect in these two particular animals and these two particular animals, but some of these animals seem to maintain the same levels as what were observed in controls. So overall, I kind of invite you to check out that manuscript when it comes out, but this is kind of the summary of what we see. I'm not going to spend a lot of time on this, but this breaks down, this is rats and mice, males and females. We have CDMA and GSM.
So this is somewhat of an adjusted heat map, kind of demonstrating what our results are. If you look at the blocks in yellow, this is where we found statistically significant trend and as well a pairwise significance in one of the exposure groups. In the blue shaded boxes, this is where we saw a significant trend or a particular pairwise significance between one particular group and a control. Green were not significantly significant, but increased in 2 or more of the treatment groups, and everything else we did not see any measurable effect.
So clearly when we got this information in from the laboratory, we looked at it. We have had many people, many eyes look at this information, and overall the conclusion is that you come down to at the end of the day, even taking into consideration all of the information on historical data, the same kind of things that Linda talked about, and you come down to the end of the day, is it more likely that it's related, or is it more likely that it's not related? And the majority of people, and I will say it's not uniform, it's not unanimous. The majority of the people that look at this data set say it's more likely that it is related, that these, certainly the schwannomas, and we have less confidence in the gliomas, they are related to radiofrequency radiation more so than they're not related to radiofrequency radiation. So that's sort of the line at which we've come down on. Pleased to appear to discuss research supported by the National Institutes of Health, National Institute of Environmental Health Sciences, and the National Toxicology Program on exposure to radiofrequency radiation from the use of cellular telephones. I'm John Bucher, Associate Director of the National Toxicology Program. Cellular telephones use radiofrequency energy or radiation for mobile communication. Wireless communication devices are used by more than 270 million Americans. With so many users, this could translate into a significant public health problem should their use even slightly increase the risk of adverse health effects. While the weight of current scientific evidence has not conclusively linked cell phone use with any health problems, we and other scientific organizations believe better data are needed to establish any potential risks to humans from the low-level radiofrequency radiation exposures associated with their use. The Food and Drug Administration nominated cell phone radiofrequency radiation emissions to the NTP for toxicology and carcinogenicity testing. The nomination was based on the following concerns. There's widespread human exposure. Current exposure guidelines are based on protection from acute injury from thermal effects. Little is known about potential health effects of long-term exposure. And sufficient data from human studies to clearly answer these questions may not be available for many years. The NTP is working to provide information that will help clarify any potential health hazards from exposure to cell phone radiation. We're in the initial stages of conducting toxicology and carcinogenicity studies in laboratory animals using specially designed chambers to provide exposures that simulate those of cell phone users in the United States. The rats and mice will be exposed to radiofrequency energy from the 2 technologies, CDMA and GSM, currently used at 2 frequencies, 900 and 1900 megahertz. Because of the complexity of these studies, we're working with experts from the National Institute of Standards and Technology. NIST scientists have developed a system that provides uniform exposures to radiofrequency radiation to unrestrained rodents in the frequency bands used in mobile communications. This design allows for exposures for up to 20 hours per day, in contrast to the most comprehensive rodent cancer studies carried out to date in Europe using restrained animals, where exposures were only to 2 hours per day. The system consists of 21 chambers assembled in Switzerland and installed in IIT Research Institute laboratories in Chicago. The chambers are essentially shielded rooms with a transmitting antenna radiating radiofrequency fields and rotating stirrers to generate statistically uniform fields. The NTP is conducting studies in 3 phases. Pilot studies to establish field strengths that do not excessively raise body temperature. Subchronic toxicology studies where animals are exposed to various subthermal field strengths for 1 month. And chronic toxicology and carcinogenicity studies exposing animals for 24 months. The studies include both sexes of rats and mice and pregnant female rats, allowing us to examine potential health effects from exposures starting in gestation and continuing through old age. The pilot studies are nearly complete. Subchronic studies will begin early next year, and the chronic toxicology and carcinogenicity studies will start in late 2010, finish in 2012, with peer review and reporting in the 2013-2014 timeframe. I'm going to show some pictures of to give you some sense of the magnitude of this operation. These are the chambers that were designed and built in Switzerland and shipped to IIT Research Institute in Chicago. You can see they're large enough to be placed on a crane and dropped through into an underground laboratory facility where they're obviously being received and moved into place. Go ahead, Michael. And then here's a picture of the final series of 21 chambers.
I don't understand what the chambers are for.
These chambers are where the rodent studies are going to be carried out. These are the exposure chambers where the radiofrequency radiation will be exposed to the animals.
And you can vary the levels and all that.
Varying levels, yes.
Doctor, you may have covered this in your opening statement. I missed it, but how long will it take you to do your analysis?
For the particular studies that I was just describing, the analysis will be taking place in 2013 and we'll be reporting in 2014.
And why does it take so long? Just because it takes that long in the lab to
put
data together?
There is about a 3-year time in which the animals will be exposed. And it takes about a year to analyze a study after that.
Will there be any preliminary numbers, or would we have to wait till the end to know where this is going?
It's a 3-phase study, and there will be information available from the first 2 stages earlier than that. But they won't be as definitive with respect to outcomes such as cancer.
Do you know if wireless phones were tested by anyone before they came on the market? Do you know the history of that, and you know how much testing was done or not done?
With respect to health-related testing, I do not know the answer to that. I can find an idea of that.
I think there'd be a lot of people that would be curious about that, to know if anything was done. And